Genetic engineering holds great promise for the future of humanity. A growing number of scientists believe that we will soon be able to engineer and change our genes in a way that will help us live longer and healthier lives. David Sinclair is a geneticist at Harvard Medical School. He believes it's possible to unlock the fountain of youth, but how much should we really tinker with our own nature?
Nothing about our lives is natural. Maybe the oxygen we're breathing is natural, but everything else is unnatural. It's human-made, it's man-made, and we change our environment. And tackling diseases and tackling aging is also natural. That's what we do as humans. We don't accept misery and frailty as natural ways of life. We should not be doing that for any disease, and we should not be doing it for old age either.
Since before the first Homo sapiens walked the earth 200,000 years ago, we've been shaped by our own inventions. We evolved from tribes of foragers and scavengers to hunters and gatherers, agriculturalists, industrialists, and eventually modern-day digital technologists. All these advancements have had profound effect on our species, but we haven't stopped there. Biotechnology is bringing about another age of humanity.
Well, there are two types of information in our bodies that are essential for life. One is genetic, and the other is epigenetic. Epigenetic is the term for any process and structure that governs the way the genetic information is packaged and read by the cell. Essentially all of our cells have the same genome, but what distinguishes a brain cell from a liver cell, and what allows a fertilized egg to become a 26 billion composite of different cell types when it's born, is the epigenome. And the epigenome, I believe, is the reason that we age. A nerve cell in an older person is no longer fully a nerve cell. It's starting to move around in so-called Waddington landscape space or epigenomic space, and it's becoming a different type of cell. A nerve cell in an old person may be partly a skin cell. I mean, think about that. No wonder we start to lose the function of our retina. No wonder we start to forget things if our cells don't maintain their epigenomic information. Question is, though, can we slow this down? And can we reset the system? Is there a reboot? Is there a backup hard drive of this early setup that we can access and restore that structure? I believe that it's possible.
In the last few years, we've seen the development of new gene editing technologies that were much quicker and easier than ever before. New discoveries in gene editing technologies are popping up everywhere in the world, and experts predict that we will see many more in the coming years. Many scientists believe that genetic engineering is the future of our evolution. It provides us with a chance to give ourselves any traits we want, such as muscle mass or eye color. Basically, anything is possible. Jennifer Doudna is a biochemist known for her pioneering work in CRISPR gene editing, for which she was awarded the 2020 Nobel Prize in Chemistry. She believes that the technical obstacles to gene editing have been overcome, and that the world is now rapidly approaching the day when it will be possible to make essentially any kind of change to any kind of genome.
Every living thing that we know of on our planet has a nucleic acid that encodes the genetic information, and for cells, that's DNA. This is a technology that is enabling in many different areas of biology. Scientists are using gene editing to alter the DNA of animals like pigs that are envisioned to be good organ donors for humans, and using it in two ways. One is to remove endogenous viruses from the pig DNA that could otherwise potentially infect humans that received organs donated by these animals, and the other is to make the organs in these animals more human-like, so they're less likely to induce an immune reaction. And that's actually work that's going on both in academic labs and also in companies now. This work is moving forward quite quickly, and I think that most people would agree that this is an exciting potential application of this that could solve a real problem, which is the scarcity of organs that are necessary for donations.
Athletic performance will also be affected heavily in the future. We will be able to modify genes that lead to better performance or make it easier for different sports to be performed. This could be done through gene doping. Instead of injecting DNA into a person's body for the purpose of restoring some function related to a damaged or missing gene, as in a gene therapy, gene doping involves inserting DNA for the purpose of enhancing athletic performance. Decades-long research in mice suggests that in the future, despite the potential risks, this technology could be used in humans. It would make us faster, our muscles stronger, and even improve reaction time. Ultimately, the rise of gene therapy suggests the possibility of improvement in mental characteristics such as memory or intelligence. Although these discoveries are encouraging, Sinclair cautions that people set their expectations realistically. There are many ethical concerns that have been raised about human genetic engineering, but this hasn't deterred many scientists and engineers from developing new gene editing technologies. Dr. George Church is a professor of health sciences and technology at Harvard and MIT. He believes that almost everything will be better because of genetics.
So the projects that I find most compelling and exciting in terms of applications are transplantation of organs. There's a gigantic need for that. Gene drives to eliminate malaria, and then for developing nations, and then aging reversal for industrialized nations where most of the morbidity and mortality is due to diseases of aging. You want to get at the core of that. And then once you have all of those things, which are drains on our economy, if you can solve all those, then you can reduce, you have more money available for things like space, where we really need to get off the planet to avoid supervolcanoes and asteroids. And that has a genetic component as well.
As genetic engineering technology approaches an unprecedented era of human gene editing, the ethical implications are beginning to arise on how to balance our desire for longevity and enhancements with our fears over the misuse of this technology. What is the moral responsibility of scientists and humans towards future generations? Is this an opportunity for human progress or a looming disaster in the making? We are beginning to reach the point where we can no longer ignore these questions. With technological advances in molecular biology, like CRISPR, that allow for specific gene editing approaches, many scientists argue that there are strong potential risks to human genetic engineering.
I would hope that initial uses are limited to real medical need rather than what we might consider to be enhancements. I think that we need to be thoughtful about putting in place appropriate guidelines and frankly, I would say regulations that really establish a set of principles that there's some price to be paid if you cross that line. And the challenge is always how to do that. And of course, science is global now. It's very hard to imagine quite how we would regulate or maybe enforce regulations globally. But I think we have to be just very thoughtful, thinking about how we can put in place a set of very clear requirements that might turn into regulations ultimately.
Gene therapies have advanced in recent years, but are still in a gray area of regulations. As with any new technology, scientists are cautious. Once we start tampering with our genetic code, who's to say what else we could do with it? And if we can genetically modify humans for the better, should we hold back due to moral concerns? The ethical dilemmas that arise as we are forced to contemplate such possibilities threaten the foundation of science and medicine. To date, gene therapy has only been used in a very limited number of patients who face a very limited period of time or likelihood of survival. We need to be careful with human genetic enhancement, as there is a risk of random edits that could have permanent consequences. We still don't know about the interactions with other genes that could cause harmful reactions. Enhancing human characteristics and capacities through the use of reproductive technology and human genetic engineering is a topic of ongoing scientific study, controversy, and moral debate. There are many different consequences and ethical implications of human enhancement and genetic modification. Some ethical concerns about this possibility include unequal access to genetic enhancement, or even a widening gap between genetically enhanced individuals and normal ones. The prospect of gene modification is a double-edged sword with numerous dangers lurking around every corner. No one can predict all the challenges we face in the future in making genetic engineering safe and secure, but there is no question that the development of genetic engineering will profoundly affect the future of humanity. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this.